Now we apply the small angle approximations to the situation we looked at in class today. We have slope 1, slope 2, angle theta 1, angle theta 2. We don't have to find angle theta 1 and angle theta 2. We can simply use the slope 1 and slope 2 to get the information we need as follows. Okay, so the momentum, we're looking at how one momentum vector projects onto the other and how much momentum is lost in the collision, what magnitude of momentum is lost. We can draw the P2 vector, the P1 vector. It's going to be parallel to ramp 1, so that this angle is going to be theta 1. And this angle is theta 2, and the P2 vector is parallel to this ramp, so that the P1 vector makes an angle theta 1 plus theta 2 with a P2 vector. So we can sketch P1 vector, the P2 vector. This angle is theta 1 plus theta 2 . The projection of the P1 onto the P2, or like actually what we're trying to find is the perpendicular component of P1, the component of P1 perpendicular to P2. So I'm going to get rid of that labeling of the angle and label it up here so I can sketch the projection, the perpendicular component. Okay, so here's our perpendicular component of P2. Here's the perpendicular component. Projection line here, should have dotted that. So, I'm sorry, that's the projection of P1. That's P1 perpendicular. And what is that equal to? Well, the magnitude of P1 perpendicular equals the magnitude of P1 times the sine of theta 1 plus theta 2. Well, that's approximately equal to the extent that this angle theta 1 plus theta 2 is small to the magnitude of P1 times, in the first place, the tangent of theta 1 plus theta 2, which is approximately equal to magnitude of P1 times theta 1 plus theta 2. And theta 1 and theta 2 are in turn equal to the tangents of theta 1 and theta 2, but I'll leave a little bit of the argument to you. That's magnitude of P1 times slope 1 plus slope 2. And you should think this connection through. How do I get from here to here? The point, though, is that if these are small slopes, and if their sum is still a small slope, this approximation for the component of P1 perpendicular to the incline is a valid approximation. And we do have small slopes for the situation that we're trying to analyze. And we're trying to figure out the discrepancies in some of our data, because our data don't seem to be consistent with everything that we're assuming. However, this part of the analysis we can take home with us. It's valid, it's true, and we can quickly calculate this, as I'll illustrate on another video.